right, thank you very much. All right, tell me, buddy.
Number 36.
All right, 36. Here we
I was
go.
kind of confused on some of the wording.
Well, I am grateful to help, so let's do it. A chord KM is 24. Now it says it's perpendicular, right? So automatically I can write down 12 and 12. That's what I think is important. And the diameter is 36. So immediately I can understand that I can't put 36 in, correct? So I know that the radius is what? And I have always told people these types of questions are always the hardest because you have to draw your own line. So I always tell kids, generally, if you get confused, go to the center and draw a line to the other points that are on the circle. That will clarify things. All right, and this is a common question on standardized tests. So that makes this JM what?
18.
Yeah, and this 18. Now from there, I can predict the rest of the questions. It might say, what is LH? Or it might say, what is JL? Right? But now we know it's just a Pythagorean triple, not a triple, but it is a Pythagorean theorem. And again, I'm just going to constantly review 18 and 12 have a common what? So this is 6 times 3, and this is what? 6 times 2. So this leg is going to have to be 6 times the square root of 5. That's what I was hoping everyone can do. And you will dazzle your teachers next year if you can do that. They will say, how did you do that? All right. Is everybody comfortable with that being 6 square roots of 5? Then they will ask, what is LH? And then you will reply that LH is simply what? You are awesome. 18 minus 6 radical 5. That is hard to see. All right, that is hard to see. All right, unless you just say, for example, if I said JL was 5, it's easier to see now that LH would be 13. But because there's a radical, people think it's harder, and it's not. All right, so what? What? Doing the Pythagorean theorem, right? 6, you see it's common 6s, right? And then 3 squared minus 2 squared. All right. Now let's read the questions. Let's see if I was close at all. Name a triangle that includes JL, JLM, JLK. Find the length of the 2 sides of your triangle, which we did, correct? Use the Pythagorean theorem to write the equation that includes JL. Solve the equation to find JL. So we took care of all that. Does everybody agree? All right, again, that for whatever reason is I'm glad we did that problem. That's always a difficult thing, all right, for kids to see. When you have to draw in a radius, all right, that's what's difficult. So you need to make a note to yourself, all right, somehow, all right, that's the tricky part to this unit. Anybody else? Thank you for that question. Anybody else? Good, Harrison.
On question 13.
All right, let me jump up to 13 real quick. What are you thinking here, buddy? Now remember, measure is a what? Degree. Measure is a degree. All right. So I'm trying to find DE, right?
Yeah.
So I'm trying to find this arc, the measure of that arc. Now it says the diameter is 12, CD is 8, and arc CD is 90. And I really think there should be a degree symbol there. All right. Because if they just say 90, you might think it's a what? It's a length, right? So it's actually 90 degrees. You with me on that, Harrison?
Yeah.
So now can you tell me what is arc ED or DE? Yeah, that's it.
Okay, but here's our question. If, you know, the angle or the, like, you know, the angle for the arc DE, would that be 90 degrees?
Okay, I can tell you what's 90. If I draw from C to A and A to D, that's supposed to be a 90-degree angle. You with me?
Yeah.
That's 1/4 of the circle. But they don't know how to draw very well, so it's a little distorted.
Okay.
Make sense?
Yeah.
You are welcome. Anybody else? Anybody else before I take this up? See how you guys are doing? Oh, Lexi, good for you.
34.
Let's take a quick look at 34 and see what's up with that. Yeah, I like all these questions. All right. So which of the following is a valid conclusion that can be made based on the figure? All right, so right off the bat, I'm noticing that this angle is congruent to this angle right here, correct? So that would make this arc congruent to this arc because they're both central angles. And then I can say for sure that this chord is equal to this chord. You agree with that? So now RS is congruent to TU, I believe that. Arc RT is congruent to arc TU, I believe that. Now arc RS is, wait a minute, arc, oh, RS, I can't even read. So I'm looking at RT. Does RT have to be congruent to TU?
No.
Sorry, I misread that. RS is congruent to arc TU, right? But I don't know that this angle is equal to the other two angles, right? Now, somehow if we could make that a diameter and divide it into 2 or to 3, then we might consider it, right? So I don't know if that's equal. So it looks to me like 1 and 3. Anybody else? All right, good deal. All right, let me pause things for a moment. Okay, so the most important thing I can tell you today is we had a central angle, and we said from this example up here, if I were to draw angle GD, or try to draw GD, and then if I were to try to draw GF, I'm trying to remind everybody that this angle is the same as this angle, right?
Yeah.
All right, so that is a central angle because the vertex lies in the center of the circle. This right here is called an inscribed angle because its vertex is on the circle. All right, now, do those two angles look the same?
No.
No, but we can say that there's a relationship between this inscribed angle and the arc. Is it bigger or smaller? Definitely smaller, right? So you just have to remember that if this is X, this is X, and this is X over 2. All right, that's X over 2. So it's not really that hard to prove, but that angle, the inscribed angle, is always half of the intercepted arc. It's always half of the intercepted arc. All right. Now, something else I want to show you, right? When you have a circle, all right, which was, believe it or not, when they figured this stuff out, this is how they knew how to construct a right angle. They could always make an exact right angle because you can draw a circle rather easily with the most primitive instruments. But drawing a 90-degree angle wasn't as easy for some reason. So they found out that if you draw a circle and you draw the diameter and you draw an inscribed angle whose endpoints are on the diameter, what have I just created? I just created a right angle. All right. Now, if I come over here and draw another one, let's say, for example, over here, and I draw from here to here. Well, I try to, and from here to here, I just created what? Another right angle, right? Now, again, that's just something, in my opinion, that I don't need to memorize. I can kind of recreate it. All right. Now, for the rest of this, let's describe the inscribed angles of a polygon. Now, if, or as in inscribed angle of a triangle intercepts the diameter or semicircle if and only if the angle is a right angle. So I'm right here, guys. Sorry, I'm kind of stuttering a little bit. So I'm right here now. So that's what I just demonstrated. That if you draw a diagonal or a diameter, and then you draw a triangle and the endpoints are on the diameter, then you create a right triangle. Then if a quadrilateral is inscribed in a circle, then the opposite angles have to be what? Supplementary. All right. Now, to me, that was kind of obvious, because if I draw this right here, right, then this is a what? 90 degree, and this is a 90 degree. So those are what? Supplementary. Does everybody agree with that? All right. Now, the other way to look at that is, now if I draw AC, is that a diameter? No, right? But watch me and follow along to see how easy this is. This is how many degrees right here? Wait a minute. Do we know? We don't really know, correct? So that's X. Does everybody agree with that? So then what would be the measure of this arc from here to here? Right, 360 minus X. All right. So then I'm trying to show you, all right, simple, this here to here. All right. This red arc, what would angle B be? Using the 360 minus X. That's correct. It's half of the arc. Does everybody agree with that? So it'd be 360 minus X divided by 2. Then what is angle D? X over 2. What happens if I add those up? Almost. Yeah, equals 180. Look how easy that was. Is everybody with me on that? All right, now again, I want everybody to be confident looking at this. You can just say that's 180 minus X over 2, right? Plus X over 2. These guys cancel. That's how I got the 180. Everybody with me? So if I'm writing something up here and it doesn't look right to you, let me correct it real quick so you can see the algebra, how simple that was. All right. So what does that mean? Given that there are 360 degrees in a circle, whenever you inscribe a quadrilateral, the opposite angles are always going to be what? They're always going to be supplementary. All right, always. What? Because we just learned up here that an inscribed angle is half the intercepted arc. We just defined it as an angle whose vertex is on the circle. So this right here, look up, this right here is the intercepted arc, right? DGF is called a central angle. DEF is called an inscribed angle. The inscribed angle is always half the arc. Now I understand what you're saying, because it's kind of difficult to see in this picture. It's very difficult, but let's do this just to help you out a little bit. All right, if I were to take this piece right here out of the picture, you might be able to see it a little bit more clearly, right? This right here now, if I were to draw this right here and this right here, this from here to here has to do with this arc. Do you agree with that? So if I call this, if I call this something that's unknown, the red is X degrees, or we could say this even. Some people like this. If I call this X and I call this Y, then what is the measure of arc BAD? No. What does it say it? It's 2x. Come on, guys. Can everybody tell me that the red arc is 2x? Everybody happy with that? Because in a minute, I'm going to ask you about the other one. So this right here, this right here, what's the measure of that arc? There we have it. Now, what's the red arc and the yellow arc add up to? 360, because that's how many degrees in a circle. So bear with me. So 2x plus 2y must equal what? Divide by 2. X plus y equals 180. That's how simple that is. Everybody okay with that now? You understand that, Mary, now? All right. So again, sometimes when they complicate the shape, sometimes it's easy to just white out or try to eliminate or redraw it without all the other lines in there. All right, because I agree that's overlapping is kind of annoying. I think basically that's it. All right, that's basically it. All right, so let's do a couple of problems, then get to the harder ones, and you can do the easy ones. All right, so let's just quickly take a look here. So everybody's going to tell me arc AC is how many degrees?
72.
72 degrees. Angle N,
31.
31 degrees. And QSR, 226. Anybody have any issues? All right, now here's something that's really cool right here. That's very hard to see. Not really hard to see, but can someone please tell me the measure of angle U?
2x plus 9.
We definitely don't know the lines are parallel. We definitely don't know. That's a good thought, but we don't, well, she's right. We don't know that the lines are parallel. Because visualize it if I did it like this, right? You with me? It doesn't, it's kind of a bad thing. I wouldn't draw it so it looks that way. Come on, someone else tell me, what's the measure of angle U? Lexi, tell us. Come on, tell us.
60.
Tell me.
You could like do 2x plus 9 equals 30, and then whatever x is, plug it in.
Why does 2x plus 9 have to equal 30?
No, 180.
What?
I don't know, I was just guessing.
Well, you would be correct if those were radii.
Oh.
You see what I'm saying, right? That's the difference between yesterday and today, I think. They're not necessarily radii. All right, and it's surprising how it is kind of hard to see. All right, so someone please tell me this. What do you think?
If you did 30 plus 2x plus 9 minus 180 equals the top angle, and then you can find the other top angle because the vertical angle theorem.
Well, watch this. Please tell me, someone, what the measure of this arc is. 60. So anybody have any problems with that being 60 degrees? You can say, I don't know, I don't see. This is the problem with some of you. I'm trying to get you to talk. If you don't know, why? It's nothing embarrassing about not knowing. What?
How did you get 60?
Well, I saw 30 degrees and I saw that this inscribed angle is half of the arc, or the arc is what? Twice as big as the angle, the inscribed angle. That is correct. You with me now? Do you see it, right? So now I'm asking, what is U?
30.
Now everybody sees it, right? Obviously, it's what? It's 30. How do I know it's 30? Because it's half the arc, right? So now, here's the other thing I used to try to show kids to demonstrate something, which didn't seem to make sense to me at first, but watch. Here's this. If I draw this right here, and I draw this right here, and then I come way over here, and I draw this from here, and then I draw here. What's true about these two angles that I just created? They're the same arc. So if they're the same arc, then they must be the same angle, which was really cool to me at first because it just didn't seem like that was true, right? No matter how close I get or how far away I get, those angles are all the same because they intercept the same arc. This is the arc that they're all intercepting. Sorry, guys. So this right here, all three of those angles are now what? Congruent. So we now know that those are 30. So now everyone should be able to tell me, even though intuitively you could have just said 3x plus 4 is probably what? Equal to what? There you go. So we can just do the mental math there. So what is that? X equals 5. All right. And if X equals, oh, I didn't even see the question. The questions are kind of labeled weird because there's two questions for each figure, right? So angle U we said was what? 30 degrees. And now it's asking about T, not X. 19 degrees. I'm assuming that's the same thing. So you can do 6 and 7 by yourself. So let's check out 8 and 9. So what is the obvious measure of angle Y?
180 minus 2x plus 12.
How much?
90,
Why?
because it's a triangle.
It's for the
In a
diameter.
circle.
Yeah, it's an inscribed angle whose endpoints are on the diameter, right? So this right here is how many degrees? 180. So angle Y must be what? Must be 90. All right, then what's true about X and X plus 12?
They equal 90.
They equal 90. Don't tell me X plus 12 plus 90 equals 180. Right? We already know this is 90. So that means the other two must add up to what? 90. Agreed? So now we just have 2x plus 12 equals 90. Right? So X plus 6 equals 45. So X is equal to 39. Is that right? 39?
Yes.
So X is 39. And then W would just be 51 degrees. All right, so let's do 12 and 13. So now we have an inscribed quadrilateral. So what do we know is true?
The opposite angles are 180.
The opposite angles are 180. Now, if we wanted to, we don't even need to know that. We could just say those angles all together add up to what? 360. All right. But to me, it was easier just say 3x equals, or 3x plus 75 equals 180. Hopefully you're seeing what I'm doing. X plus 25 is equal to 60. So X is equal to what? 35, right? That was kind of silly because it would have been easier to do this one, right? So now that we know X is 35, we don't even have to do any of that. That was dumb. Measure of angle S has to be what? 70. Waste of my time. And R is how much? 105 degrees. Everybody seeing that? That was a waste of time. So don't do what I do. All right, I'm pretty happy with that. I don't see anything hard. Okay, let's just get a little wild and crazy. What is the measure of angle R? Because why? Come on.
You add.
So what's QS, guys? 100. So this is what? 50. Everybody happy with that? All right. So MP, I'm trying to find this guy from here to here. So let's just do it. Tell me. How much? I think so. 118. Well, you tell me. If this is 31. So what do I know? So now how do we get 118? Yeah. All right. I don't think anything is difficult as I'm looking through here. All right, let's look at this right here. In a circus arena. A circus arena is lit by 5 lights equally spaced around the perimeter. What is the measure of angle 1? Come on now, these are a little bit of thinking questions, a lot better than the other questions we just did. So let's try to calculate the measure of angle 1. What do we got? Yay, right? Easy. 72. Now, come on, don't sit there and just go, okay, I'm going to put 72 and I don't have a clue what they're doing.
I thought it would have been 32.
I got 32.
Okay, well, I'm totally fine with that. So you understand, this arc from here to here is how much?
72.
Is that 72? Right? So then from here to here is also what?
72.
Is that happy now?
I
Go.
thought it'd be like 360 divided by 5, and then that's. the
That's true.
arc.
Totally true. You're 100%.
Divided by 5 would get the angle.
Yes, ma'am, you are. You did everything right. You're just not seeing that there are 2 72s in that.
Oh,
You see what I'm saying, right?
yeah.
So this guy right here is also 72. All right, everybody okay with that? Anybody? All right, I'm assuming you guys are good. All right, I don't think the stop sign is that hard, right? Although, yeah, that's good enough. I don't think that's hard. Let's come down here and see if there's anything harder. All right, let's do 35. Start out with 35. Somebody help me. That was kind of easy. Somebody said D. Is everybody okay with that? A is good. 1 only. Anybody else want to put their thoughts in? Another D. Tell me. What? B, good. What is it, Lexi? Tell him. D. Anybody else? All right, so does it contain at least 2 right triangles? Yeah, because if this is a right angle here, then when I draw MCK, do I agree now? That would have to be a diameter. So if that's a diameter, then we agree this one has to be, right, even though it may not look like it. So there's at least 2 right. All right, now I'm not sure at least 2 means it could be 2, but is there 3 or 4? I think it should say quadrilateral has 2 right angles. All right. Is everybody okay? That's okay, right? Everybody's good with number 1? So is MLK a semicircle? Yeah, most definitely, right? And it doesn't say anything about adjacent angles, correct? So that one's not true. So I'm happy. D is correct on that. All right, let's try 34. Let's see if that's harder. All right, let's go figure it out real quick, and hopefully we'll all agree on this answer. Oh, good, Nate.
I got C.
I got a C so far. Anybody else?
I got B.
What?
B.
Another B? A D, good. Anybody? A B?
B.
A C?
B.
B again?
I got B.
Good. So we got more B's, it looks like. Come on now. If you're not saying something, come on, get in the game. Try. Who knows? Aiden, good.
I got B.
D, good. B,
B.
B.
B. Yeah, mostly B's. So let's figure this out. So everybody can tell me, what did X equal? X is what?
24.
I think it's
It's C.
right. 5X minus 30 equals 90. So X equals 24, right? 120 divided by 5 is 24. So if that's 24, 48 minus 6 is 42, correct? And then that's twice the arc, 84. B.
Oh, I forgot the-
I picked the one.
All right, finish up, please. Finish this up for homework. I appreciate it, guys, very much. Good day, good day, good day.